Hello everyone, this is the third part in our tutorial how to prevent SQL injection with NodeJS and Sequelize. In this video we're going to talk about layers of defense. Please make sure you are starting from the first video if you really want to understand the material. Let's start. In cybersecurity there is a famous concept of defense in layers. It means that you protect yourself against an attacker in different type of layers, and if one layer breaks or an attacker finds the vulnerability in the layer, the other layers will protect you and prevent the damage. In our context, we're going to talk about three layers. The first one is DB management or database management. The second one is input validation. And the third one is Sequelize function. The first step is DB management, but I would like to start with a general note about the mindset that we need to have when we're dealing with the cyber security attacks. If you are an attacker and you want to attack a company, it doesn't matter if it is for business information or it is because you want to make damage to the company. You really don't know too much information about the company. You may know the name of the company, you may know information that is on the internet, but you don't know the database structure, you don't know if the database is SQL related or not. And the first thing you want to know is to figure out the structure of the database and to fetch as many information as you can. The attacker will do this with the next approach. We will use the current routes that you are already using and try to change the attributes or the fields in order to fetch additional information. For example, if you have a post route that receives attributes, you may change one of the attributes to SQL query and see what will happen if you will send it. These operations or these tries will yield to SQL errors on your side. You may catch them also on the input validation layer, but these errors are great for you to understand that someone is trying to understand your database structure. So the first step we want to do is to save these SQL errors and be alert when something wrong happens. The second step is to return only necessary values. You need to think that if you don't expose a column or information, the attacker doesn't know this information. So if, for example, I want to expose a unique identifier for my entity, let's say I have a table of users and I want to expose unique attribute that in other routes you can use it in order to update the values of the users. I can do it in two ways. I can send it the original ID, or I can generate UUID or encoded ID that will be used. This UUID or encoded ID needs to be unique for every user. If I will send the original ID, the counter of the counter in the table, I can expose how many users have been created for 1 hour, for 2 hours, and the attacker can take this route, do the query on the morning, see that you have 20 users, and he can do this check again and send the same route, and now he knows that during the day only 10 users were generated. This is additional information that the attacker may use. The third but one of the important points is to manage your user capabilities. Especially the user that your server is using. You don't want to give too much permissions for one user. If you don't want to edit one table, make sure that your user don't have these capabilities. The third point is general, but I decided to put it here. Keep your software updated, including external packages. I think it's a very clear point, but all the time when you're using open source, a lot of security vulnerabilities are exposed, and you need to update your software anytime and do it manually every 1 week, every 2 weeks to make sure you don't miss any update. Our second layer is input validation. Input validation is the gateway to our application. It helps us to make sure that we are receiving only the expected payload from the user. The second point is that front-end check is not enough. And let me explain because it's a little bit confusing. Today, it is very common that application has input validation inside their front-end code. Let's say, for example, that you have a form and you need to enter your email. The submit button will not be clickable until you enter the email with the right structure. This check is very nice and it can be done in the browser or inside the mobile app or something like that, but it is not enough for us. Because if an attacker wants to harm our system, he can use proxies to skip this validation, or he can use the postman to post the request directly without going through the front-end code. The next two points are going to talk about the two optional values that we can have. The first type of values that we can have is known values. By known values, I mean that the value you expect to receive is inside a closed list. For example, gender. You have female and you have male. And today there are more, but let's say it's a closed list. And you have something like unknown values. For example, name or a last name. All you do have is that this value is a string, but you don't know the length of it, you don't know how many spaces is going to be included, so it is unknown for you. You cannot have a closed list and say all the values are going to be taken from this specific list. Let's start with the known values. When we are dealing with the known values, it is the easy case. We should validate the input inside the backend code, inside the input validation code, and we should configure the database to accept only these specific values. When we are dealing with unknown values, it is more complex, and I have a few tips for you. The first tip is that we should use whitelist instead of blacklist. But you might ask yourself, what is a whitelist and what is a blacklist? A whitelist is a list that you say, all these options I accept in my application. The blacklist, as you may suggest, is the opposite. You say to your customers, this list I'm not allowing. This list is forbidden inside my application. We should always use the whitelist method, because the blacklist is very problematic, and I want to show you why it is so problematic for us. Here I am at the OWASP organization. They wrote an article about SQL injections. There are many methods that they are covering in this article, but I want to talk about this specific method. The select query that they are trying to do is doing the select title and text from the news table, where ID is equal to 10 or 1 is equal to 1. In this case, you might say that I want to block any usage from the numbers 1 until 1 million. The attacker should try to play with it, and it can recognize that you block the numbers until 1 million, and then enter here the number 1,000,001 or 1 billion or something like that, that will make this query fetch all the fields inside the news table. And let's continue. Let's say that you recognize this vulnerability, the comparison part that is always true, and now you want to block this specifically, and you add regex and you block it. But the next day the attacker can come and say, okay, he blocked this statement, so instead of equal I will use not equal. For example, before 1 is equal to 1, I'm going to use 2 is not equal to 3, and this will make his query fetch the relevant items. So this was the recommendation to use whitelist instead of blacklist. Next, there is a recommendation to use regex, especially when you are dealing with something that has a structure. For example, an email it has a structure that you can check. Today they are packages that checks emails easily. We can also check the types. For example, you expect to receive a number. You can check that you receive a number and not a string. And this is a good point, expected length. Let's say that you expect to receive passport ID, and the passport ID is between 5 to 8 digits. You can also set this rule that the value must have this specific length. Our last layer is Sequelize function. In general, we recommend that you will use only the basic functions of Sequelize. Functions like find one, find all, update, delete, and so on. The probability that you will have any security vulnerabilities in these functions is very low, so if you can keep using only the basic stuff, just use them. But there are cases when you need to use raw queries, when you want your query to be very fast, or when you need to create a complex query and Sequelize does not provide you the tools to do it. So in these cases, please notice the following. First, read the documentation of raw queries in Sequelize. In the documentation, Sequelize recommends that you will use bind params and replacements. These methods are much safer than just use the raw query. If you want us to make a video about it, please write us in a comment and we will explain more about it. The second point that you need to keep in your mind is that there is a module in Sequelize that is called query generators, and this works when you provide the values and it creates the query safely for you, and you just need to run it. And the third point is you need to keep your Sequelize version updated all the time. There are many users that are using Sequelize, but security vulnerabilities are still found and you need to be updated to the latest version. Most of the attacks are coming from attackers that doesn't have too much technical background, so they are using some open vulnerabilities that are found on the internet and find the users that are not updated to the latest version. That's it, my friends. We talked about the DB management layer, we talked about the input validation layer, and the Sequelize function layer. If you find any of these tips that we talked about useful, please thumbs up and subscribe to the channel. It helps us to grow our channel and to provide more value for you. See you on the next one.